Good afternoon. Thanks for being here. And you guys had the choice to attend yet another large language model session, but you believe in something that we do, and you chose to be here. So really appreciate that you being here. My name is Dong Kim. I'm the Senior Director of Architecture at Ontada, and I'm here to present on our journey to implement real-world data and evidence platform using Lakehouse architecture to transform the fight against cancer. So just a little bit about myself. I am at Ontada responsible for delivering the next generation data and AI platform using Databricks. I have over 20 years of IT experience within healthcare and in finance. Before joining Ontada, I was responsible for designing and implementing a data lake. Back then, they didn't have Lakehouse, so it had to be data lake at Veterans Affairs and as well as CMS, Centers for Medicare and Medicaid Services. So this is agenda to be covered during today's presentation. We will spend some time on each one of these topics. And just a spoiler, I left the goodies towards the end. So if you find the topic to be interesting, just put your alarm on for 20 minutes and wake up and come back at the last 10 minutes. So first on the agenda is giving you introduction on Ontada. And I hope this will provide you with a description of each of the products that we have and how they fit into real-world data and evidence cycle. Ontada is oncology, data science, and technology, a business within McKesson. We specialize in generating insights within real-world data and evidence to accelerate life science research. And we develop clinical and operational technology to support community oncology providers. We have a number of provider solutions as well as life science products. First, on the provider side, we have iKnowMed, which is our oncology electronic health record system. It is used by the nation's largest community oncology network. And it leverages continuously updated library of oncology treatment regimens and provides a diagnosis-level biomarker test and lab recommendations. CVP, Clear Value Plus, is a decision support tool. It matches its patient to right evidence-based treatment options while providing integrated clinical and financial information. Ontada Health is our patient portal. It was created to increase the value of digital engagement between the patients and providers. And we have Practice Insights, which is the performance analytics tool for providers. On the life science side, we have real-world data products, and these are products that are developed to support oncology, decision, and research. They provide the views into the full cancer patient journey. We also have provider engagement channels, which offer provider education, patient education, market research. We do have real-world research, which is Ontada's offering to help providers achieve outcome-based value. So before we get into the discussion of our Lakehouse implementation, I'd like to spend some time to understand what and why real-world data and real-world evidence are so important for cancer treatment. So on this slide are some of the cancer stats within the United States. It gives some perspective on the kind of the impact that disease has on the patients themselves, as well as their families and their friends and their coworkers. So within the United States alone, it is projected that there will be 2 million new diagnoses of cancer this year. And unfortunately, 600,000 people will die from the disease. It is the second leading cause of death after heart disease, and it is the leading cause of death among women between the ages of 40 to 79. And it is the leading cause of death for men among the ages, between the ages of 60 to 79. But we have some good news. Within last 30 years, the mortality rate has decreased by 33%, but we still have more to do. So what are real-world data and evidence, and why are they so important for cancer treatment? First, let's take a look at the definitions of real-world data and evidence. FDA defines real-world data as data relating to patient health status and the delivery of healthcare collected from a variety of sources. And these sources, they can come from electronic health record systems, such as Ontada's iKnowMed, and then they can be genomics and oncology data, claims and billing data from the payers, such as your insurance or CMS, and then they can be surveys like social determinants of health and patient-generated data from the wearables, the smartwatches, and digital devices. And why is real-world data important? It is important because it enables the researchers to go beyond the data gathered from traditional randomized controlled trials. RCTs, or randomized controlled trials, gather data from a controlled sample patient population, and this limits the findings to within the characteristics or the outcomes of the cohort examined in the trial. On the other hand, real-world data can be collected from many number of population subgroups, and this can give broader perspective on the efficacy as well as the potential adverse effects of cancer drugs. When real-world data is analyzed, it becomes real-world evidence, and FDA defines real-world evidence as the clinical evidence about the usage and potential benefits of risks of medical products derived from the analysis of real-world data. And there is greater emphasis on real-world evidence by the US Food and Drug Administration with the passage of 21st Century Cures Act when it comes to regulatory decision-making on drugs effectiveness. So this is a simplified view of what we just discussed. We have real-world data collected from a variety of sources driving real-world evidence generation. These evidence collected can be used for drug research and regulatory approvals, and the cycle continues. And this is a quote from our CITO, Segun Moodley. He's our Chief Innovation and Technology Officer. And I'll give you a few seconds to digest what Segun is saying here. But essentially, it highlights the fact that battling with cancer is personal. A drug that works on one patient may not work as well on another patient. But as we gather more data and evidence and turn those evidence into insights for producing personalized treatment options, we can truly turn those personal battles into collective transformative victories. So with that information on real-world data and evidence, I'll give you an introduction of Ontada's data management infrastructure, our implementation of Lakehouse. So Ontada's data management infrastructure, or DMI, is the next generation data and analytics platform that is built on Azure Databricks. It replaces the legacy Oracle data warehouse as well as the genomic processing infrastructure that we have built within AWS a few years ago. It is the centralized analytics platform for Ontada. It was created to fulfill Ontada's mission to improve the lives of cancer patients by using real-world data and evidence generation to accelerate life science research. And it achieves its objectives by improving data curation and standardization from initial ELT to user reporting, and to act as a single platform for both life science and community oncology users. So let's go over some of the pain points that organizations with no Lakehouse face today, okay? First, data silos. Organizations without Lakehouse, they usually end up with multi-platform architecture due to the limitations within the various analytical tool stacks they pick to meet business objectives within organization's history. And those business objects, they evolve. For example, they may start off with a data warehouse or a traditional BI analytics, often in their on-prem data centers. And because of the new need for advanced analytics, they create a different stack within the cloud. And despite the best effort, this multi-platform architecture often creates data silos, which leads to data duplication. And having multiple types of data makes it increasingly hard to harmonize between different data sets across different platforms. And now having multiple platforms also creates challenges for creating proper access control, especially when you are considering multiple user groups. Data rights, de-identification, and other compliance-related requirements makes the access control, as well as other aspects of data governance, exponentially difficult. It puts a lot of pressure on the data teams, and as an adverse outcome, the deliveries to the business gets delayed, and you eventually end up with very unhappy customers. So why did we choose Databricks? First of all, Databricks Lakehouse, it simplifies the architecture. No need to manage infrastructure for separate components within your analytics environment. Within the platform, you have a SQL warehouse with Photon to make the queries run faster. You have notebooks, integration with GitHub, MLflow for model tracking and serving, and the best of class Apache Spark clusters. Built-in automation with Databricks workflows allow orchestration of data processing, machine learning, and analytics pipelines. You can also use a Databricks CLI, REST APIs, and Terraform module to integrate and automate with your existing tool stacks. Centralized data repository using Unity Catalog is possible, which enables us to use common strategy for data standardization and data quality implementation. Lakehouse is one platform all analytics needs, from BI to descriptive, predictive, prescriptive, generative AI, NLP, you name it. And it also provides you with infinite scalability, and there is no contention of the resources among different user groups. It gives you the flexibility and agility for the teams to run their workloads independently without negatively impacting other users. So this is a 30,000-foot view of DMI architecture, and I'll start from the bottom. In terms of the user provisioning, we are leveraging SCIM, or System for Cross-Domain Identity Management, to sync the users from our Azure AD to Databricks accounts level. And from there, we assign and manage each user and user groups to Databricks workspaces. In terms of access control, there are many objects that you need to consider, such as workspace objects, clusters, SQL warehouse, jobs, secrets, alerts, dashboards, queries. We went through many iterations of considering which users and user groups need to have access to which Databricks objects as well as Databricks assets in collaboration with our compliance team. And there is a need for good policy for managing personal access tokens. You should think about using Token Management API to review and manage tokens lifecycle. We made sure that our personal access token management is in compliance with McKesson's security policy for password management. For master data management, we intentionally decided to start small. We looked into the entity resolution accelerator that is created and maintained by my good friend, Luke Bilbro from Databricks. And since we are dealing with PHI information, we're monitoring who is accessing which data asset as part of the compliance requirements. And we have implemented proper tagging strategy within our clusters and SQL warehouse to allow us to determine which user groups is incurring the cost for which type of workloads, and this can be used to help us determine the return on investment later on. On the left-hand side, we have data coming in from various relational database systems, including NoSQL database such as MongoDB. We have a number of data ingestions that are happening using CSV. And for data ingestion, we are leveraging both batch data ingestion as well as change data capture using Click Replicate. We also are experimenting with Debezium and Kafka. And once the data has been loaded into the bronze layer, we are using autoloader to lend them into bronze layer, and then we are using dbt to apply the transformation to our common data model within the server and gold layer. And this is the first time we've been using dbt. Our development team, they love it. And the users of the data, the Tableau is being used for practice insights, one of the products that I mentioned earlier. And then there are SaaS users who are creating life science products using the data that we have created. And then we are training NLP models using John Snow Lab, as well as a number of open source projects. So some of the highlights on our use cases. First use case is for the development of real-world data products. We need to bring in data from several sources, and there will be varying degree of data completeness, quality, and each downstream systems, they may have their own rules in terms of standardization. So we needed to harmonize the data to provide consistent views, and that's why we have created Common Data Model, which is the driver for real-world data products. It is oncology-focused, it is scalable, It is built on FHIR, which stands for Fast Healthcare Interoperability Resources. And because it's built on FHIR, it is interoperable. We're leveraging FHIR MCODE, or minimal common oncology data elements, as the base model, as well as the FHIR genomics reporting implementation guide. The second use case is to be able to abstract information that are captured within our EHR, or electronic health record, iKnowMed, as unstructured data. And these are doctor's notes or clinical notes. For this, we built our own NLP models and to address the cost of manual information abstraction from those unstructured data, as well as reducing the time to market. For the third use case, we're expanding the real-world data product lines, including clinical genomics data product offerings. We need to be able to ingest, process, and analyze raw genomics files. And I don't know whether you have seen these files. There are some files that are smaller, like VCFs and TSVs, but then like the BEM files and FASTQs, they can be in the magnitude from 10 gigabytes to 40, 50 gigabytes per file. And if you multiply that by the number of patients, then you can kind of see the magnitude of the storage size that we have to deal with. It requires a lot of computing resource to process these files, and then storage management, it poses unique challenges on its own. Fourth use case is providing self-serve reporting and dashboards. So the actual migration. Let's look at the timeline first. We started on this journey Q3 of last year, less than a year ago. We set data management infrastructure vision. And in Q4 of 22, we executed a contract with Databricks. And then we explored 2 pilots with Databricks people. First on a migration of our genomics pipelines from AWS into Databricks. And the second one was a migration of our NLP development from SageMaker into Databricks. And at the same time, we also deployed our workspaces within Azure subscription that we had. And Q1 of 23 is when we really started the development. So we started the development of the migration of life science workloads. We got Databricks professional service engaged. We built out a data validation framework, and then we built out a data ingestion framework at the time. So the complete migration of life science workloads took place within 3 months. And in Q2 of 23, we have delivered on our common data model, and then we delivered our product to our customers. So this is the nuggets that you've been waiting for, the migration lessons learned. And I want to thank Asegren again for giving me insight into this slide. This is his suggestion, and I absolutely agree with him, that you need to have executive sponsorship. And that comes in the form of a financial commitment. You need to have both initial and continued commitment from the executive sponsor for the overall success of the program. And in order for you to receive the continuous funding, you have a little bit of homework to do. You have to provide the clarity on the total budget and frequent updates on the progress that you are making. And you need to consider this as a long-term journey, an investment that the company is making. And with any investment you get, you need to be able to produce the return on investment. You will need to have a good strategy on internal communication to demonstrate the value the new platform is bringing for the business. And there needs to be frequent vision and execution alignment, first with your executive sponsor and the delivery team, and between the executive sponsor and then Databricks industry vertical leadership. For example, Segren, who is our Chief Innovation and Technology Officer, and Michael Hartman from Databricks, he's the SVP of Regulated Industry, they have quarterly sync up. And this is important to reassure and strengthen the commitment from both sides. And there needs to be alignment between DMI delivery teams and Databricks account team, and they are fantastic to work with. We met at least every day for almost 3 months. And visualizing this will look like this. So Databricks and Ontada, we were on this together. And Databricks, they ensure to let us know that our success is also Databricks' success. And you should also consider taking advantage of Databricks Business Value Consulting. It is free for, I think, their strategic customers, and it helps to explain to your CFO, the person who is writing the check, why you need the investment that you're requesting. Okay? Lesson learned, number 2. We have to have a strategy for parallel execution. So when we started on this journey of migration, we first identified our key resources, the data subject matter experts who were there when the initial data warehouse within Oracle was built out, and those who knew where the skeletons were buried. They are high-value assets. We need them for both for migration as well as keeping the lights on or running the legacy platform until it is retired. And we had to ensure that we maximize their knowledge and expertise. Be ready to juggle. Think about your migration strategy. Is your strategy, is it going to be lift and shift and then modernize afterwards, or are you going to rebuild from scratch? You also have to balance between the business priorities and address technical debts. And for that, you need to have a frequent alignment with your product owners. Risks, assumptions, issues, and dependencies. From the day one, we kept a track of RAID. I hope you do too. And our RAID, it is visible across the different teams, plus the leadership, and each team member is empowered to raise any concerns early on so that we can reevaluate and prioritize with our product owners as often as we need it. And seriously consider leveraging Databricks professional service or take advantage of their SI partner ecosystem. So raise your hand if you are confident that you can get those qualified Databricks developers from day one. They are hot commodities, right? So I don't think it's going to be realistic, but try to leverage their professional service as much as possible while you are building the delivery team. And my recommendation is to pair your data SMEs with Databricks professional services to come up with a work breakdown, and then have your team members participate within those migration teams. Lesson number 3, start conversation with your DBs early. You need to have complete picture and complete understanding of the workloads that are currently running within your legacy data warehouse. And you need to negotiate the time slot for your ingestion job to run with a DBA as early as possible. Whether you are doing batch data ingestion using JDBC or incremental ingestion using CDC, server may not have the capacity to add new workload. And they may have to do some upgrading of their existing servers. There will be resource contention, CPU, memory, and etc. Ensure that your critical, the jobs that are currently running on the legacy system is not impacted by the new workloads that's introduced. And you need to know that change data capture, it requires supplemental logging to be turned on. And it's going to take up significant amount of disk space within your legacy server. So if the disk space is scarce, then it'll determine the amount of time that your CDC job can be backed up. And that's going to be critical if you think about some of the potential failures that it may occur. You also need to have a testing. You also need to have a strategy for testing ingestion within your QA environment. You need to plan out the QA environment. You need to do the data refresh from the production into the QA. And for CDC, you need to come up with different strategy. And you need to have collaboration with DBAs and QAs. Lesson learned number 4. This is very important. You should write it down, and if you can, repeat after me. Not everything can be automated. I hate to break the news, but until ChatGPT takes over the universe, you're not going to have complete end-to-end automation in terms of the workload migration. So you need to continually do manual coding as well as validation of the codes that are generated. My recommendation is to focus the validation on the data that is generated using the new code and pipeline rather than inspecting code by code comparison, unless you have to optimize your code. And you also have to manually generate DDLs. This is a limitation that you may be facing. And also, what is your strategy for time zone conversion? Databricks, their default time zone is UTC. And if your data warehouse is currently using different time zone, then you need to have a conversation with your product owner right away so that you can come up with a consistent way of converting the time zone. And within Databricks, time zone can be set at the session level, at the cluster level, or you can set globally, which will have an impact on all the SQL warehouses that are created within the workspace. So you need to kind of think about that. And also, there will be limitations as to how much of data that can be converted from Oracle Pure SQL procedures and functions into Spark SQL. So you may have to break out into leveraging PySpark for those instances. So lesson number 5. So this is the strategy that we use for testing, and the mileage may vary. So for testing, we have a static copy of the data from our legacy data warehouse to test out the transformation pipeline, okay? So the way that we do this is that we do the complete copy of the data from Oracle into a catalog within Unity Catalog, and then we also create another catalog within Databricks that is populated with the code and pipelines that we have converted over, and then we have manually updated. This gives us with one-to-one matching or apple-to-apple comparison. And for data ingestion validation, we leverage live data, meaning we do the comparison between Oracle and also with Databricks. And if you think about it, if you have billions of rows of data that you need to make sure that you're bringing into the platform, ingestion itself, as well as the validation of it, it's nothing less than black magic. But it is possible. You also have to spend good amount of time and effort building out your validation automation framework. We do 2 levels of validation. One is the count and checksum validation, and then second level of the validation is logic validation, which we need to work with our life science users to make sure that they are getting apple-to-apple data. Lesson learned number 6. Monitor, send feedback, and repeat. There are 2 areas of monitoring that we focused on. First is on financial. We need to monitor and prevent any runaway cost. And we need to provide early feedback on consumption. And this really works. For example, we had an instance where one of the user groups, their usage we saw was going up without any reason. So we sent an email to that group, and then we told them what was happening, and they took care of it immediately. And then we saw the consumption coming down. You need to frequently validate the usage and also leverage a FinOps principle. And then second monitoring that we do is on compliance. Who's using what data, when, and why are they using it? We established a matrix of user groups and the data assets, and we developed an access approval process that includes our compliance team. So whenever there is a new request coming in for access to data assets or from user role changes, they have to go through the compliance team before a user has access, and then we keep the record. So in terms of leveraging Unity Catalog, I already covered these topics, so I'm not going to rehash them, but one thing that you should look into is leveraging Unity Catalog SDKs that's provided by Databricks. When it comes to doing compliance reporting, these are indispensable tools. So benefits of Lakehouse. Data availability. Users as well as the team members who were part of that initial legacy data warehouse build out, they noticed a significant improvement in terms of how we ingest the data and also having the data available. And they are also getting quality data. Our life science users are able to expedite their work. Our life science users, they keep a spreadsheet of time it takes for certain queries, right, against the Oracle and then Databricks, and they let us know, okay, this is the time that we got from Oracle, this is the time that we got from Databricks. In some instances, we're seeing 10 times improvement in terms of query. So, and Databricks also enhances user collaboration using Notebook, and there is obviously GitHub integration. And it allows us to do everything within one platform: data engineering, data science, workloads, ETL, SQL analytics. And it is also future ready. Our life science team, they are able to produce new life science products using this platform, and we are able to leverage all types of data, structured, semi-structured, unstructured data, and be able to run any type of analytics that's out there. So shameless plug, before I end the presentation, we are on Databricks Marketplace. Check us out. Search using Ontada. You will see a listing of clear data views, which is one of our life science products. And also, we are picked as one of the finalists for Databricks Data for Good Awards. I think, do we have time for Q&A?